All right. I thank you all for coming out tonight, and I thank Ticketmaster for allowing us to present. I'm going to talk to you about using Marpa, which is a module in Perl for parsing, which is a very common task that programmers need to do. So people often regard it as a very complex thing to do, that it's like a magic black box. You put text in, and out comes an effect or an analysis. But if you add Marpa to your Perl program, it makes parsing extremely easy. And it's a remarkable thing. The biggest mistake, this is almost like my talk on security, don't roll your own crypto, don't try to write your own parser. It's a very complex area. It turns out that the kinds of parsers people have had in the past were all things like would use recursive descent, or would use like a recognizer, like a regular expression, and then try to branch on that basis. But it becomes a very difficult thing if you have to implement backtracking. And that's why it's nice to have a system like this. So we're talking mostly about using a domain-specific language, or DSL. So these types of systems are very useful. We use them for scripting, we use them for templates. Doug showed us his template system, for example. And so PHP templating, for example. And a description language. And it's interesting that there are DSLs now which are written for like a technical manual or a procedure. It looks like English, but can be read by a computer or a person. And it says very specific things like, the aluminum slug is placed within, this container, and then we're going to use a certain particular mill to cut it. And it looks very procedural. And then, but that because it's not exactly English, it's more machine readable. It's actually useful as dual use for a description language. And there are more things being written like that. And then a simple example could be like a calculator grammar, which I'll show you how to implement that in Marpa and Perl. And it could be Perl itself or C++. These involve extremely complicated parsers in order to make them. But Marpa can handle them. So why is it called Marpa? Jeffrey Kegler wrote the module. He's a computer scientist in Northern California. And he's always been interested in fast parsing in Perl, and he's interested in the history of Buddhism. So Marpa Lotsawa was a translator, and that's why the code is called Marpa. And so he was very famous because he translated lots of works on Buddhism into Tibetan. So the advantage is that it's much easier to use than most parsing systems. So a lot of you are familiar with Lex and Yak, and you have to write a separate information, separate grammar, if you will, for Lex, the Lexer, which is the first phase of parsing, where you're identifying tokens, and that's your tokenizer. And then after you Lex things, then you can apply yacc, which is your compiler. So yacc would basically take the syntax that was in BNF syntax, our standard form, Backus-North form, for writing a grammar, and would then take the individual tokens, also called lexemes, and these lexemes would then be turned into the program, the script that you're trying to execute, for example. The better system with Marpa is that it's scanless. The lexer is part of the same document, so that you don't have to worry about this, and it's actually, they're sort of part of the same process to do both lexing and yacking, or scanning and then applying a grammar in order to do the actual parse. And so it works really well with Perl, and it's very fast. This system is actually faster than most of the grammars, even with ambiguity, lots of recursion. And they use J. Early's algorithm. He's a famous mathematician and programmer who did a lot of work on parsing algorithms. So there's a modified Early algorithm. And then it's very superior to recursive descent. It's actually much faster than systems like Lex and Yak. And it's got an XS module so that it's not pure Perl. But here's an example of a calculator written with Marpa in Perl. Let's pretend that it's got use strict and use warnings up there, right? But this is the domain-specific language that we're defining. So we've got here document, and it's a very simple thing. And then what this will do is it'll take expressions like 42 times 1 plus 7, and it'll parse that and get the value out. So I'll take you through it real quickly. There's always got to be just some basic things. So we're going to do longest match for a token match is what we're looking for, and that's something that is almost always what you want. So that, but it's a default you have to specify that we want the longest possible token match for when we get tokenizing, and then we have to specify what an action is. And so this is sort of like our default rule for the semantics of what a parse means for that particular level of the grammar. And then we have a grammar we're defining, and the colon equal is our operator that basically associates a left-hand symbol. These are called L1 rules, G1 rules, which are then they're used basically to specify the order of the parse. So you have to go from top down. So the calculator can be an expression, and then this is the whole text is going to be matched by this, and that's what first means. So this is like your top level node. Then you've got a factor, and a factor is defined as a number, but it's also top level, so it's not something which is going to have any value by itself. So what first really means there for an action, and there's an action attached to each node, as you can see. The action, it means return the value of the first token, is what that computes to. Then there are terms, and the term times factor, so this is how you define multiplication, and we specify an action do multiply, which we'll define later. That's going to be a callback or a semantic closure, or, just like you usually have a vertical bar, it could be a factor by itself, in which case just return the factor. And that could be a term, so since the term, there's left recursion here, and it turns out that left recursion seems to work best for Marpa. That seems to be a very good way to set things up. Now, it can also be an expression, and you see expression's a little higher than term, and that's how you handle the precedence of the multiplication operator, that you expect that to associate, because like it's supposed to, multiplication should associate and have higher precedence than summing. So that's how you manage it, is just simply by having this type of thing that can happen. Term here is subordinate or is a lesser level, lower level, than expression plus term. There's also some things happening here, like recursion. And then also a term by itself could just be the value of the term. And then these rules that have tildes these are actually lexing rules. So these are more rules for the structure of what constitutes a token. So number is defined as digits, and digits is defined using character classes just like in Perl. So we could say \d for digits, \s for white space, and then the plus makes it a sequence rule, just like in a regular expression. You can't say \d plus without the brackets. You need the brackets for this. But you could stuff more characters in here too. If you wanted to use hex, you could say \x, but you could also say 0 to 9, 8f, and maybe 8f again, uppercase, if you need to do that. And then there's a special token for discard. That's how you get rid of white space. And then white space has to have a definition, and that's white space characters. So anything that \s is defined for in your system. So that's a very simple toy grammar. And then to activate it, you have to create a new object. So Marpa R2 we're using. There's actually an R3 that's come out, but R2 is the most stable version so far of Marpa. And the scanless is the type that doesn't require a separate lexer. And it's a nice situation. And so you create the grammar object, instantiating it with source from the DSL. This will throw an exception if there's a syntax error in here. If there's something strange going on, you've defined a token that doesn't end or something strange. And I got many of those errors before I finally got it working right. And then the input, you could specify, I have up on my website, I've got a version of this where it takes the input from standard in. And so I've got that running. I'll show you as part of a demo. It's a little bit more fancy parser. And then the value reference, for historical reasons, is always stored as a scalar reference. And you parse, and the parse is you take the input, give it a reference to the thing. It could be this little tiny string. It could be a string that's, it could be 15 megabytes long. It doesn't matter. And then a package name. So the package name here is going to be the Perl package that contains the callbacks that the actions that you specify are needed. And so that's do add and do multiply. So these callbacks come with extra information that are not necessary. We only want term 1 and term 2, and those are values of tokens that are already associated at a point in the stack, basically. So do add adds the 2 and returns it. Do multiply multiplies the 2 and returns it. Very simple. And so when you run this, as you'd expect, it would calculate this and spit out 49. And it's a very simple example, but it's a very powerful system. So the scaleless interface, they're using the term SLIF for scaleless interface grammar. There's actually multiple other arguments that refer to the Perl documents. They're very good, very excellent, well-documented module. Source is the only one that's required, but you can do other things, and you could specify a lot of kind of hooks. So there's a module that allows you to look at the progress of a parse. And there's also a module uses GraphViz to pump out syntax trees of your grammar. And very beautiful charts if you want, with lots of boxes and arrows and everything. And then we have the default pseudo rule we showed you. That just sets the semantics and the longest acceptable token match. So you saw that. And that's typically what you want. It's historical, basically. There was a time when that it was not felt to be so good to have the longest acceptable. And I guess that's a little bit like greedy, the extra question mark in regular expressions, where sometimes like like a very quick and dirty regular expression to match a parenthetical expression, you're better off setting the greedy attribute on your this character set that's not the closed parenthesis or closed angle bracket or something, because if you don't, it may give you, it'll gobble up everything from there to the end of the next parenthesized expression. And so that's what this is doing, is trying to make it more discrete. And this here is this array specification basically is setting up the form of the callbacks, so that the argument list that ends up going to your callbacks is specified, so you know what you're going to get. And it's going to be by the name and the values that you're looking for. And it's understood that there's a left-hand side and a right-hand side, and that's the T1 and T2. And so these are G1 rules. The G1 rules are the structural rules, which you think of as yacc rules. Those are the parser. And then L0 rules, those are lexical rules. Those are like the original low-level token synthesizing rules. And the Backus-Nerv form is basically, you get a single left-hand symbol, and then the operator makes it the structural G1 rule, and then you have one or more right-hand symbols. And then there's an adverb, and the action gives the semantic meaning of what that level of the parse indicates. And when you use the special action first, then that's what I meant by saying that the value of the rule is the value of the first token. And that's how you extract the meaning. So if you're at that point in the parse, it's the string 6, the value is going to be numeric 6. And that's what's going to end up in the syntax tree and then get sent to your callback for the semantics. So these are L0 rules. So that's the tilde operator. And then we want to get rid of things, so that's what discard does. There's an interesting post I was reading that in some cases you want to preserve white space. So if you're parsing, let's say JavaScript, and you wanted to save it, like you could minify the JavaScript so it would load faster. You could also save it in a form where you've figured out what's happening, like you're trying to reverse engineer something that had been obfuscated. You could recover the white space. If you want, you don't have to discard the white space. And may be valuable depending on what your parser is supposed to be doing. And then it's that sequence rule. So we have the character class the same as Perl. And you can remove comments too. So it's a little more complicated, but if you go through this, what you can see is this is what gets rid of your favorite hashtag for getting rid of for a comment in Perl. It's the same thing that's used internally in Marpa. So that you could put comments in there with # or hashtag. And then what's happening here is that you've got a more fancy lexing system, and it's interesting, so you can have single word token names, but you could also have a token name That's multiple words if you put it in angle brackets. So then you can make things that make a little more sense and spell it out more in English. And then you can see how a terminated hash comment has to have the pound sign, it has to have the body, and it has to have a vertical space character, whatever that is. So that must be a new line or form feed or a cash return. And those are defined here, vertical space characters. And then the hash comment character this is what's actually the body of a comment is defined with your caret. So it's anything that doesn't match these things. And these Unicode things have to be like Unicode vertical space moving control characters too. And then it has a lot of things that I think are very familiar to Perl programmers, like the idea that the hash comment body is hash comment character star. So 0 or more, just like in a regular expression. So you could think of Marpa as like a very higher level kind of regular expression system, but it's way more powerful. But I don't want this regular expressions, they're cool. We love them. So it's very easy to extend. So this is a new calculator program that now does division and subtraction also. And that's all you have to do, is just add the text in red. That you just have to define, well, there's another operator, slash operator, and it's going to do divide. And there's another operator for the expression, which is at the slightly lower level of precedence. So you can handle association of the operator. And that's we do subtract. And then nothing else changes, it just made a little fancier input. And so it's going to print 70 once it goes through everything. And we've added the do subtract and we've added the do divide. So it's very straightforward how that works. And I think that what's exciting about this is you can imagine how easy this is to extend. You could add bitwise operators, you could add all sorts of things. And you could add unary operators too. And so you could build it up to the point where it's as sophisticated as Perl itself. Yeah. So I have a little demo to show you. Very little demo. Let's see. Okay. So basically, I created a demo that actually includes the code for including comments. And so you can see that comments are going to be properly there. I have anti-malware. I have to do an update, I think. Do that afterwards, right? It's amazing. 45 times 2 plus 5. So, you know, you can verify that it's a working system for parsing these small strings. And I could do 100 over 2, and I'm going to say pound plus 5. So this better not print 55, because that would mean that the comment was not being elided or deleted. Oop, that didn't work. 100 over 2, pound plus 5. That's right. Sorry. This one doesn't have that, doesn't know about division. Let's do 4 plus 5, pound plus 5. All right, so see what's happened is that it's used the logic I gave it to get rid of comments to take this piece away, pound plus 5, so it only read this part of the expression. And so it's very straightforward. And back to that. Yeah, so I think that it's very clear that Marpa could be very useful. It's definitely seems to be quite a bit better than these other parsers, things like Lex and Yak, which I remember working with many years ago. So I think we would do a great deal of work with Marpa. We'd be able to maybe create much more robust systems, especially for scripting, things like that. So the next thing I'm thinking about is trying to find some new way to look at templating languages. So I have a templating system for our medical information system. And it has some high-level constructs. Doug had shown us an if-then statement like that you could use to exclude portions of code. that are in your HTML, for example, and so for output. I have a system now where I can take a data table, anything in the SQL table, and I have it's an expression that starts off with a bracket and says for ID equals select information like age of patients, and then a where expression, and then each column has a definition, and then a close bracket. And so I laboriously did the parsing for that without knowing about Marpa ahead of time. And then I could rewrite that code with Marpa, and it ought to be quite a bit faster. It'd be very interesting. Go ahead.
Don't stand back quite so far. You're just going off camera.
Oh, I'm sorry. So I got through that a lot faster than I expected. Any questions? We'll go back to the code. Anyone have any questions about the code and how it works?
So you can do larger than one-digit numbers and put spaces in there too, right?
Oh, absolutely.
You put 45 space
Yeah, I got
plus
space,
space 235.
I have to show you that. 45,
And use multiple spaces too.
multiple spaces, plus
232.
232. So that works. And then you could do 40, you want to do no spaces? Yeah, no spaces I already did. But you can, it definitely, because I said white space \s plus. It'll take one or more, and it'll discard them. But if there's a match, a direct match, there's like the \b in regular expressions, that directly connects two things, like the 2 is right next to the plus. It's okay with that. It'll accept that. So you don't have to say \s star, because that's being discarded. And they want to discard things that are non-null. Yeah.
How about one with the precedence is off, like 2 plus 3 times 4?
Okay.
These are simple unit tests.
Exactly. Yeah. So that's good. And so I think that's an important point, because if it couldn't do that, you'd be very nervous that you've lost the precedence. So this of course, it shouldn't be 20. You know. So I mean, that's very interesting that it is able to do that. And then the way that was established was not by having a precedence table like you'd have to have, or assign precedence like you'd have to do in other systems, but simply because of this, that you have the level of definition, it naturally falls out of the level of definition. So that's why you put these things that should have equal precedence as terms, and then these are expressions that are built up. And that's a very mathematical notion, of course, because that's the way you want your algebraic things to look, too.
Do you have like another level for like exponents and stuff?
Yeah, what you could do, because exponents, basically, you could extend the idea of number so that you could have, instead of saying number here or factor, you could probably add right here, and I have not done this, but I could see how it's possible. So imagine putting a vertical bar there, and then put number, and then star for exponentiation, or a caret if you prefer, and then put another number, and there's your, and then of course you could put floating point numbers too. You have to define them differently as to this way number is defined here. But you could imagine defining them in a different way. And the value, I think, is that it should be easy to extend. So I was trying to think of a way to show people how simple it is to extend, that you just do a very little change, and all of a sudden it's that much more capable. So in terms of the comment stuff, I took all that comment code and I just shoved it right in here. That's all I did if you go to the website. And so if you want to look at the website, it doesn't have anything in it except for these things. And that's at neuroscience.com/Marpa. And I could spend a little time talking about the author of this module. So Jeffrey Kegler turns out to be a very interesting person. He's a scholar when it comes to Kurt Gödel, who was a great logician, and who actually proved the existence of God, he says, in 1970, according to this book that Kegler wrote. So the same guy who wrote the Marpa, who is the maintainer of the Marpa module, wrote a novel. So I had to download the novel and read it. It's interesting. It's an interesting read. It has a lot of Eastern mysticism in it, and he tries to explain the way Gödel's proof works, and it's a fascinating read. there's also some spooky stuff in there about how Gödel had to become an American citizen. He had fled Austria during World War II.
G-O-D-E-L?
Yeah, G-O umlaut D-E-L, Kurt Gödel. So he was Einstein's friend.
And if you read the Bach book?
The Gödel, Escher, Bach.
Yeah.
Yeah, Douglas Hofstadter, great book. Yeah, fantastic book. Yeah, so Gödel basically proved that math is not complete, that you could basically, you can't express all true statements with a set number of symbols. That some true statements exist which are not expressible in the language, so that you can't just enumerate all possible equations, for example. There's an infinity of equations, and you keep making stuff up. And then, in a sense, that sort of means that reality is unlimited in a good way, because it's not, there's no way to predict everything that could happen. So it's interesting how he tries to explain that as a proof of God. It's just a fascinating book. Just a little plug there.
Vegas depends on that, right?
Sorry?
Vegas depends on that.
I think Vegas depends on that. That's if it weren't for that, Vegas wouldn't exist. The house has got to win at the end of the day. So if you look at the website, I've given you the code for the version which has the event loop so that you can put in things. So the way I wrote that, by the way, I wonder if I can pull it up. Let's try to pull it up for you. So you could say quit, and then it quits without giving you a huge warning. Let's see if this will work. Okay. This is the calculator demo. So what you can see here is that I did the same thing, and this one's the simpler calculator that doesn't know about the division or subtraction, just for simplicity. But I just added this loop here. So just arg v and a quit, and I didn't even have to chop it, and it prints it very nicely. And there's definitely the hidden new line there. But I did it this way to exit if I got quit. You could have defined quit as a token, and then the action could be to exit. And that would have been legitimate also. But it seems that once you have such a powerful tool like Perl, it would be just as easy to do it this way. And a higher level control thing, so that the parser never sees the word quit. Yeah.
Real quick question. Actually, I was thinking about that. If you chomped it, actually, would that make your comment removal code work?
It might.
It would get rid of the vertical white space, which is the new line.
It's true, but there's unterminated final hash comment.
Gotcha.
Yeah, and I got to tell you, this is not my code. This code I got directly from Discovery.
Right. I forgot about the inverse
Yeah.
of that.
That's right.
Okay.
So it's got hash comment characters, so it can see there's a hash comment body, but no vertical space character. So that would take care of the situation where it had input that didn't have a new line. Yeah, it had no new line.
Okay.
Yeah, so I think the point I wanted to make by showing you this was that it's possible to extend the language any way you please, and you could put meta tokens, things which are going to be tokens that have command and control, like quitting a session, could have been part of the grammar too. And then that might be valuable for some domains of implementation.
Not to mention, this structure is a good way to just play with the grammar. You just run it. You've got
You just
like a
run it.
little shell, and you just type your stuff in. You see if it works.
Exactly.
Or if it blows up.
Exactly, and it blows up spectacularly.
You didn't add division because otherwise it would take over the world.
That-
It's
it-
good you left that out.
I'm afraid it would become Ultron, I'm really afraid of Ultron. Voiced by James Spader, go figure. They had to get James Spader. I think that the real power of this is that you can imagine extending it in interesting ways that you could have, like for example, most of the time, like if let's say you're developing a device driver, like really low-level stuff. The low-level work that people might do, you'd want to be able to run that kind of a continuous development loop where you keep iterating. And so I could imagine a situation in which you make a little change, you have to assemble, you have to upload it or flash the firmware and then run it and see if it'll work. And keep going over and over, and it's very time consuming. If you had kind of more like unit testing, where you had a number of different code branches. You had made yourself a mini language just for you to express the type of testing you wanted to do. You could create a very powerful test suite, and it would be very exciting because you'd be able to then maybe just walk away and let it run 1,000 tests while you go get a Coca-Cola or something. And it's a fascinating thing, but I think that I'll have to play with it some more. I would like to see if I could get it to do natural language processing, if I could do NLP with it. The problem is that a language like English, natural languages, are way more complicated. I've seen estimates that English might require 20,000 rules. And then, of course, you got to put all the semantics in, and you have to throw in basically a dictionary. And at that point, you've got another problem. There's not only combinatorial explosion, you've got tons of possible sentences and meanings of things, but how are you going to represent the meanings? So for a calculator, the meanings are numbers, that's easy. But the semantic domain is something stronger. So if people have tried to do things like this, and the best example I could think of using something that comes close to natural language are text adventure games, like Zork, which I played probably too much when I was a kid. But those sort of games, they had very, very simple parser for like, turn lamp on, draw sword, that kind of thing. Kill troll. And then it says, I'm sorry, you've been eaten by a Gru, of course. But I think that the exciting thing is that you could imagine that there may be some intermediate way that you could build up to that level if we used a system like Marpa. And if you had some way of incrementally adding things. So there's a project out there, a guy named Doug Lenat has a project that's been going on since the 80s called Cyc, spelled C-Y-C. And it was a strong AI project, and it's been managed to get continuous funding all these years. And what it's basically about is people putting rules in about the world, and trying to get enough information into the computer that it could do common sense kind of reasoning. He uses first order predicate logic to represent information in the world. I think for an English language parser that would be effective, we would need something along the lines of like unifying concepts. And so I wonder about machine translation and how Google Translator must work, that they must be doing something along the same lines, that if there are two sentences, you're trying to map an English sentence to a Russian sentence, the English sentence will map to the token level would be something like concept 147 and concept 126. And then in the Russian side, concept 147 is this word, and concept 126 is this other word. And then that's how it can convert the two. But because otherwise, it seems to be an intractable problem, and yet they've solved it. Just fascinating. It may be that it uses something much more sophisticated that I'm not aware of. But I thank you for your attention.